Okay guys, back with question 8. This is IBSL Maths May 2015, paper 1, time zone 2. Part B, a few more extended responses. Remember, they still start pretty easy and then they build it up to maybe having to think a little bit towards the end. Keep your wits about you, keep your thinking cap on, you'll be fine. Here we've got a function f of x, which is a, x plus 3, x take 1. Great quadratics, we've been doing these for years. This should be pretty easy. Alright, the graph has intercepts at P and Q. P0, Q0, and y-intercept at 0, 12. We can see all that from the graph anyway, so again, nothing too complicated there. Write down, so again, it's just an instruction to write it down, the value of P and of Q. P is the first point over here. What's that intercept? Well, we know that x minus the intercept is a factor, so this is x minus -3, so P would have to equal -3. And Q, well, we've already got x minus 1 there, so 1 must be the intercept there. P equals -3, Q equals 1. Write down the value of A. How am I going to get that? I've got to use my other bit of information. When I substitute in 0, the answer is 12. When I put 0 in here, the answer is -3A. So if -3A equals 12, A is going to equal -4. Does it make sense that it's negative? Yep, negative. Sad face parabola. Cool. Got some easy marks there. Find the equation of the axis of symmetry of the graph. Axis of symmetry, where does it fall? It falls through the x-coordinate, the turning point. What do we know about quadratics? They're symmetric. If this point is -3, that point is +1. Writing the answer down a little bit early. Then this axis of symmetry is -1. Read it carefully. The equation of the axis of symmetry. So the equation is x equals -1. That easy. 3 marks. I'd be showing something on the graph there to show that it's in the middle, or maybe just showing, 3 plus -1 divided by 2. Sorry, I had it the wrong way. -3 plus 1. Ugh. Silly little. Getting a bit late here. -3 plus 1. That's what we wanted. Probably just show some working to get that -1. Therefore, x equals -1. But writing it on the graph would probably suffice as well. Alright, find the largest value of f. Well, that occurs at the maximum. The maximum is where x equals -1. Although you could use, remember the y-coordinate of a turning point, just as a quick refresher, y-coordinate of a turning point in a parabola 4ac minus b squared over 4a. Sometimes that is useful. Not in this case, because what are we going to do for this one? We're just going to find f of -1. Now, given that f of x, if we just scroll up again, we said a is -4, so this is just going to be -4, -1 plus 3, -1 take 1, make it look pretty, -4 to -2. I'm getting a maximum value, or the largest value of f being 16. Write it in words, that would look even nicer. The function can also be written as a x minus h squared plus k. Oh my goodness, do we have to complete the square? Well, you could expand and then complete the square to get to that, but why would you? Because we already know the answers. We know what a is. A is -4. We know what h is. H is the x-coordinate of the turning point. So this is x minus -1 plus, all squared, sorry, and k is the y-coordinate of the turning point. Well, what was that? 16. So you could write it out like that, and therefore just make sure you know h equals -1, k equals 16. Make it really clear for them. Easy for them to reward you with marks. That is, how many marks for that one? 6 and 9 make 15 marks. Done in under 5 minutes. You've got plenty of time to check your working. Make sure you do. See you in the next one, guys.